So today we are going to start with ship's long by Chron method, celestial observation. That is how to calculate the ship's position by longitude by chronometer, and it is also called Marpas or meridian passage. So let's start. So first step is you're getting the DR position. So DR position, already, dead reckoning. It is, so we must be aware of our DR position just by putting the speed and course and getting the dlat and delong as we have discussed in previous videos. So we have a last known position and we apply the course and distance and we get the dr position and we have the dlat and departure. Now, of course, this is just a rough position because that's a dr, and we know the formulas. Dlat is equal to distance and departure, and this plane and parallel sailing formulas you can use. Now, practically, you can plot your last position on the chart, draw the course and distance from this position and measure. Or if it is quite a long distance, you can use softwares and all these things. But if you are taking sight for practicing your hands on sextant or just to be on independent means, so for sight, we can also take practically GPS position as also a DR position, and it will give you a better accuracy also to check. So we assume our DR position as 22 degrees north and 119.48 minutes east. Now we take a sight in the morning when the sun is above the visible horizon. Of course, the sun we should see, then only we can take the sight, and we measure the sextant altitude of the sun, and the accuracy, the more our accurate is the sight, so it will depend on your rolling and everything, and slowly on the accuracy of this measurement, our sextant altitude, our result will be good. So that we have a separate video how to measure accurately our sight. So it is most important to practice sights often, and it's also a requirement everywhere you should have a sight. Let us say we have taken morning sight and our sextant altitude of the sun we took as 27 degrees 22.1 minutes. So that is our altitude. The time of the sight need to be noted down precisely to the second. So let us say that the time of sight was this from the chronometer or our clock: 0833 seconds local time or 003332 GMT. Both are given here. Sometimes if not, then you have to convert as per the LIT using the longitude. Next is we have to calculate the observed longitude. That's what is our method to calculate the longitude by chronometer time. So to calculate the observed longitude by long by chron method, we have studied that we know that while for long by chron we need dr position and we need the index error, height of eye, measured sextant altitude of the sun, and time of sight. These are things we need to know. So for the calculation part, you can either do manually or by scientific calculator we have here. So observed longitude, true azimuth of the sun at the time of the sight. That's what we need to find out. This is where most people get confused. The observed longitude is not the longitude of the vessel. With the long by chron calculation, we will just get one position line of the ship. So it's a position line of the ship, and vessel can be anywhere on this position line. So with one side, we get only one position line. That's very important point for orals also and for understanding. We are not getting observed longitude does not means it's the actual longitude of the observer. It's just a position line through which we have to draw this longitude and position line. And azimuth is calculated to get the direction of the position line. Azimuth means the bearing of this body. So for celestial observation, position line is always 90 degrees from the azimuth. Plus minus 90 degree always is your azimuth. And the position through which we will draw the position line will be the dr latitude. So we always draw this position line through the dr latitude except for intercept and all, and dr latitude and observed longitude which we got in the question. So in long by Cron, we make a dr latitude, observed longitude, and our azimuth, and our PL will pass through this position. So let's calculate these things by scientific calculator. So we have a calculator here, or you can do normally also. So we put all the inputs, and then so we use long by cron of the sun, date, time we have to put in GMT. We put the DR position and the sextant altitude, index error on the arc or of the arc, height of I, and then we will get the observed longitude. Then we have to calculate the LHA and observed longitude. Observed longitude. So LHA we will get from the almanac of that time. We got 308.48.13, and GHA 189 degrees 05.7 minutes. So our observed longitude was LGHA west, LHA west, GHA east, longitude GHA least, longitude is GHA least. So here GHA is less, so longitude is east. So we got the difference 119.42.4 east, that is our longitude. The next step is to calculate the azimuth. So here they have calculated using the traverse tables A, B, C, A, B, and C, and they got the azimuth as north 89.5 degrees. So later on we will see how do we calculate. So 89.5 plus minus 90 degree is our position line. So with the side we got one position line, and we have the position through which to draw it, dr latitude and observed longitude. So here is the result of side calculation. We make this dr latitude. This is the longitude which was given in the question, and this is the observed longitude which we found out by the site. And our position line is you can see here is almost north south. Always for your marpas it will be north south, because your azimuth will be what you call east west, so your position line will always be north south in long micron. As you can see in this case, the position line is always parallel to the observed longitude. Now we for getting the position we always need a second position line. So second position line we calculate by meridian passage method. That meridian passage method we will see in the next video.